Practice problems. All right, number one. What is the speed required to place an object in orbit just above the Earth's surface? So we're going to need Earth's radius is really what that's saying, right? We're going to start off, though, figuring out what we even need or what we're looking at. And they're all going to be pretty much starting off the same way. It's going to be saying FC is equal to FG. It's going to be like that for every one of these, right? So now FC is looking for speed. So which of my formulas am I going to use? So am I going to use mv squared over r or 4 pi squared rm over t? Well, I'm looking for v, so I'm going to use that one. All right. So going back, I'm going to work my way down. I'm going to say, okay, mv squared over r. And now for fg, I've got two options. I could either use f is equal to mg, or f is equal to big G m1 m2 over r squared. And in this case, I know that it's at the Earth's surface. I know what G is at the Earth's surface. So I'm going to say, to make things easy here, let's use F is equal to mg. Let's use that one, right? So I'm going to go mg. And what's going to happen in pretty much all of these, because the mass of the small thing, the thing orbiting, doesn't really matter at all, is that they're going to cancel. So m is going to cancel with m. So all I really need here is v is equal to g times r, and then take the square root of that. So Earth's surface is, so radius of Earth, 6.37 times 10 to the 6. Oh, that was the radius. And then 9.81 meters per second squared. You get 7.91 times 10 to the 3 meters per second. So just to note here, though, if you would have chose this one, that would have worked just as well too. You would have got the same answer. It just would have been, you would have had to have the mass of the Earth in your equation or question too. Okay, so the space shuttle orbits the Earth at an average altitude of 500 kilometers. What is the period of orbit? So again, for all of these, we are going to start off with FC is equal to FG. And FC this time, though, it says, what is the period of orbit? So we need to use the other force one. So that was, oh, that's the key for this. 4 pi squared r times m over t squared. And we are looking for t in this case, right? So that's going to be equal to fg. So now, which fg am I going to use? Am I going to use fg is equal to ma, or fg is equal to big G m1 m2 over r squared? Well, I don't know a anymore, right? Because this is in orbit. A is only equal to 9.81 at the surface of the Earth, so I can't use that one. So it's got to be this one. G m1 m2 over r squared. So now looking at this, again, we're able to cancel one of our masses, right? That's the mass of like the little thing orbiting. You're going to cancel. And if we rearrange this, so if I bring t up to the right side of the equation and r squared up to the left side of the equation, just to clean this up a bit, we're going to end up with 4 pi squared. This becomes r cubed, right? R times r squared that I brought up. It's going to be equal to big G times m2 times t squared, and we're looking for t. So now next thing we're going to do, I'm going to bring this up here just to keep going. We're going to have 4 pi squared r cubed over big G times m2 is equal to t squared. And I'm just going to do this right now. We're going to take the square root of that. So now that I have that, the only thing we got to figure out now is what r do I put in? Well, the altitude is 500 kilometers, so what I want is I need the radius of the Earth plus 500 because it's 500 up there, right? I need this as my radius. So R, write this down here, R is going to be equal to, the radius of the Earth is 6.37 times 10 to the 6 meters. And it's going to be plus 500,000 meters. So R is going to be 6.87 times 10 to the 6. Whoop. What happened? Oh, I went to the... Okay. I'm back. I try not to hit that with my hand again. Times 10 to the 6 meters. All right, so that's what's going to go in for R. So I'm just going to pause it now and put all my numbers in. Okay, now we're going to see if we can put this in our calculator properly. So I'm going to show you how I would do it. So I would go 4, pi symbol's down there, so 4 pi squared, and then I could go times, and I'm going to put in brackets here, go brackets 6.87, and then e to the 6, and then on the outside of the brackets I'm going to go cubed, so to the power of 3, and then I'm going to push enter. So that's that whole top part, right? The whole top part is that, and now I'm going to go divided by, and I'm going to put everything I'm dividing by in brackets, so I know that everything on the bottom is going to go within those brackets. So divided by 6.67 times 10 to the negative 11, and then times 5.98 times 10 to the 24. And that's all in brackets, right? So I know to divide by everything. It's dividing by all of that. Okay. And then push enter, and that's what you get. But don't forget, the last thing we got to do is take the square root of that. So I'm going to go control root, and then control answer down here, right? And that gives me the answer that I just figured out there. And then push enter, and you get that for an answer. Okay, so you say t is equal to that. So then finally t is equal to 5.67 times 10 to the 3 seconds. Okay, moving down. Okay, 3. If the average distance from the sun to the earth is 1.49 times 10 to the 11 meters, what is the mass of the sun? So the hint here is how long does it take the earth to orbit the sun? So again, we can start off with, they're all going to be like this. FC is equal to FG. And, well, even in the hint here, it says how long does the Earth take to orbit the sun. So I'm going to be wanting to use the one that has time in it again. So let's rewrite this one as 4 pi squared r times m over t squared. And that's going to be equal to big G m1 m2 over r squared. And just like it has happened in every one of them, M1 is going to cancel, or one of the M's on each is going to cancel, right? And we're looking for what's the mass of the sun. Well, that's the big one, right? So the sun is the one that is going into that equation. Okay, and the other thing that we know is that time, let me write this over here, time is going to be equal to 365 days, right? That's how long it takes for the Earth to go around the sun. But we don't want that in days. We want that in seconds to go into our formula properly. So I'm going to multiply by some factor to change this. So I'm going to put days on the bottom. And if you're not sure how many seconds are in a day, let's just change it to hours first. So let's say I know there are 24 hours in one day. So if I just multiply by 24, my units are now in hours. I'm going to multiply by another factor. I'm going to put hours on the bottom. I'm going to put, well, you should probably memorize this one by now. I can go straight to seconds from here. You could have went to minutes by going there's 60 minutes and then go to seconds, but I know there are 3,600 seconds in 1 hour. So if you go hours divided by hours, so all I got to do is go 365 times 24 times 3,600. And your time is going to be this big number. That many seconds. Okay, so now that we know that, we just need to rearrange this formula for m, just for that, right? So doing that, our formula becomes 4 pi squared times r cubed now, because I moved that r squared up there, over t squared is, and over big G is equal to m2. Okay, let's move this on up here and put our numbers in. So we're going to have 4 pi squared times the distance it gave us here, 1.49 times 10 to the 11 meters. And you might be saying, yeah, but it's supposed to be from like center to center. I know people, like kids have asked me that before. The distance here is so much bigger than the distance of the radius of the sun or the Earth. It doesn't really matter, right? And you can kind of think about this as being the average distance, so it is from the center already. So don't worry about adding the radius of the sun or the Earth or anything like that. Okay, so where was I? Oh yeah, and this is all to the power of 3 divided by 6.67 times 10 to the negative 11 times our time that we just figured out. 315 360, one more 0 seconds, and squared. Okay, so you put that into your calculator, you get, whoop, sorry, made a mistake there. That should have said m right here. Hopefully you made sense of that. Okay, and your m2 ends up being equal to 1.97 times 10 to the 30 kilograms. All right, last one. A geosynchronous orbit is where a satellite maintains the same position above a certain point on the Earth's surface. At what height above the Earth's surface must a satellite be positioned in order to have a geosynchronous orbit? So first off, I just want to make sure that you guys understand what I mean by geosynchronous orbit. So if this is the Earth is rotating, right? So let's say it's rotating like this. A geosynchronous orbit means that above, let's say, this point on the Earth, a satellite would stay directly above that. So it's every time the Earth makes one revolution, the satellite also makes one revolution. So right off the bat here, what would be the period for a satellite with geosynchronous orbit? Well, it's going to be 24 hours, right? It takes 24 hours for the Earth to rotate once. It's going to take 24 hours for that satellite to rotate once. So whenever you get one of these questions that says geosynchronous, and the word geosynchronous, what that means is like Earth synchronous, right? Geo means like geology. It means like anything to do with the Earth. So geosynchronous means synchronized with the Earth's spin. All right, so we're going to start off the same way we've started off with all of them, right? Let's go FC is equal to FG. And now we want something with R, right? Because it says at what height. We're looking for R, right? Well, not just R. We'll have to subtract the radius of the Earth there to get the altitude. But we need that, and we also, like I was just saying, we're going to need period because we know that, right? We know that the Earth takes 24 hours to rotate once. So we are going to use, for FC, we're going to use 4 pi squared R times m over t squared. And for FG, we're going to use big G, m1, m2 over r squared. All right, so again, we're going to cancel one of the masses. The little mass is what we're canceling. Let's bring r up to the left side, t up to the other. So we'd have 4 pi squared r cubed is equal to big G times the mass of the Earth, in this case, m2, times t squared. Now I'm going to have r cubed is equal to, I'm going to bring 4 pi squared over to this side. So it's going to be G times m2 times t squared over 4 pi squared. And then what's the opposite of cubing something? it's going to be the cube root. So we got to take the cube root of both sides. So r in this case is just going to be equal to the cube root of big G times m2 times t squared all over 4 pi squared. But now our t, our period, remember I said that our period for this is going to be 24 hours. Well, again, I need that in seconds. So what I'm going to do is multiply this by 3,600 seconds in 1 hour. So hours cancel with hours. So time in seconds is going to be 86,400 seconds. Okay, now we just got to put our numbers in. So we'll bring this up here. So r is going to be equal to the cube root of 6.67 times 10 to the negative 11 times the mass of the Earth, which is 5.98 times 10 to the 24 kilograms. And then these get pretty long. We got t squared, and t we just figured out was 86,400 seconds. Don't forget to square it. And then that divided by 4 pi squared. So then for r, you were going to get 4.225 times 10 to the 7 meters. And that's not the same as our answer up here, is it? Well, the reason for that is because what we just found, this is the Earth, right? And this is our satellite up here. We just found this. We found from there to there. That's what R was, right? What the question's asking for is the height above the surface. So what we need to do is subtract the radius of the Earth. So we could say our altitude, let's say ALT, is going to be equal to R, what we just found, minus radius of the Earth. So that's going to be 4.225 times 10 to the 7 meters minus 6.37 times 10 to the 6 meters. Oh, leave it over here. Okay, so our altitude is going to be 3.59 times 10 to the 7 meters, which is the same as our answer up here now. Okay, so that's it for those ones. Go ahead and do your hand-in assignments now, or hand-in assignment. Yeah, they should really all be along the same lines. I'm pretty sure all of these actually start off the same way with saying FC is equal to FG. So if you don't know where to start, write that down first. That's step number one. Okay, sorry for the long video. I'm going to end that one there.